Okay, so why do you, how do you think you would prove that there's an infinite amount of prime numbers? Go ahead. Yeah. There's no right or wrong answer, I swear to God, okay? Just give me anything that comes to mind, yeah.
Okay, so I have an idea.
Yeah.
So, like apparently like when you go towards infinity, the prime numbers become more sparse, but like they don't go to zero, like the amount of prime numbers. But I guess you could like make a graph.
There's an easier way. That's a good thought, though. I mean, that there is definitely a pattern there, but there's an easier way to prove it. Okay. You know, who knows what a contradiction is? Anyone? Do you guys know what a contradiction is? Anyone? Yeah? Okay. What is a contradiction? Give me a contradiction.
Something that rebuts a statement.
Okay.
Something else.
That's good. So why don't we prove this by contradiction? Let's assume, we're assuming, okay, does everyone know what that means? Assume, we're holding this true. We're going to assume that there's a finite amount of prime numbers, okay? So we'll, okay, so we're going to assume a finite amount of prime numbers. Now, this is going to be kind of abstract, but I want you guys to think of a bubble, okay? Does everyone see a bubble in their mind right now? Okay. Put a finite amount of prime numbers, which we will denote like this. P1, P is just prime, any prime number, okay? P1, P2, all the way up to Pn, okay? There's an n amount of prime numbers, okay? That's a finite amount. Just pretend that in this universe, or this little bubble, there's those prime numbers exist in that little bubble, okay? No more prime numbers. Does that make sense? Okay, so now, how do you think we can prove that there's an infinite amount, though? What do you think the next step would be? We have a finite amount of prime numbers. Yeah, go ahead.
So find something wrong with that.
Yeah, perfect. That's exactly what you want to do with a contradiction. You want to just prove that what you assume to be true leads to some sort of contradiction, okay? So then you know that what you assumed is wrong. Does that make sense? Just logically, does that make sense, you guys? Yeah? Okay, so, let me just make sure I'm doing this right. Okay, so, what can we construct with this finite amount of prime numbers? What can we construct? We can construct a new number, right? Is that okay? Is that allowed? Can we construct a new number? Okay. Let's just call it Q. Okay? It doesn't matter what. You can call it whatever you want. Let's just say Q. Okay? What I'm going to do is kind of tricky, but I hope you guys can get this. I'll explain it after I do it. Okay, we're going to let Q equal the finite amount of prime numbers. Okay, so P1 times P2 all the way up to times Pn plus 1. Anyone know why I did the plus 1? Okay, so remember, in that little bubble, there's a finite amount of prime numbers, right? Everyone got that? Okay, so we can use those prime numbers to our advantage in any way. Okay, so what we're going to do is we're going to multiply them together, and clearly, this Q that's holding this number is going to be larger than any of these prime numbers, right? Because multiplying them all together. Okay, and obviously, if we add plus 1, it can't be a prime number itself, right? Does that make sense?
Well, why couldn't it be a prime number if you just added 1?
Well, okay, so if it was a prime number, remember what the definition of a prime number?
Yeah.
What is the definition of a prime number?
It's only divisible by itself in 1.
Exactly. So if Q was a prime number, it would have been divisible by one of these finite amount of prime numbers, right? But if we divide this Q by one of those finite primes, we're going to get a remainder 1. Does that make sense?
Right.
Okay, perfect. Okay, so now what we must say is, okay, we want to prove this by contradiction, right? So we have this Q from that little bubble, remember that little bubble, right? So, like I said, if this was prime, if there was a finite amount of primes, right? And this isn't prime, Q is not prime. Some P, or we could even say, yeah, we could call it some P. Some PM, we'll denote it PM. It doesn't matter what you denote it. Okay? So some PM that's less than or equal to P1 or less than or equal to Pn. So some number, some prime number would have to divide this if, because we know Q is not prime, right? Does everyone got that? Q is not prime, and by definition of not being prime, it would be a composite number, right? Okay, and composite numbers can all be broken down into prime factorizations, right? So it would have to be divisible by some prime. And in this universe, we only have a finite amount of primes, right? We have P1 to Pn, correct? Everyone understand that? Did I lose anyone yet? No? Okay, so like I said, we constructed a new number by just multiplying the finite amount of primes in that little bubble, okay? And we added one so it wouldn't be divisible by one of the primes. So therefore, it is a composite number. Does that make sense? Okay, so now that we have a composite number, remember by the definition of a composite number, it has to be divisible by some prime, because every number, every integer can be broken down into a prime factorization, okay? By definition. Okay, so that means that some PM, some P in this finite set, right, has to divide that, right? But if we divide P by some PM, you're going to get a remainder of 1. So that's a contradiction right there. Does that make sense? That's going to be a contradiction, because if you have only a finite amount of prime numbers, and a composite number has to be divisible by some prime number, and none of these prime numbers divide this Q, that's a contradiction. So therefore, there has to be some P that isn't in this set that divides Q, by definition. And because of that, that means we can keep on doing this. We can just keep on doing this. It's called, like, you know, do it by induction too. Just keep on doing that, and then you finally can come up with, okay, there's an infinite amount of prime numbers, because you can just keep on doing this.
Why does Q have to be composite if you add 1?
Why does it have to be?
Yeah.
Well, okay, so if I gave you a